Welcome. Welcome to the next lesson about while loops. And we're going to, in this lesson, talk about how you can compare strings for equality and use that in a while loop test, and also how to validate user input. So this is going to be a lot about how do you make your programs handle user input and so forth. And the first thing I want to talk about is this notion of of sentinel values. So when our programs are repeating code, a common situation is that you're going to ask for user input until the user is done. So you allow the program to continue running until the user decides they're done entering code in or entering numbers in. And so to stop the loop, we can use what's called a sentinel value. It's just a value for the loop test to say, okay, if I hit this number, I'm going to quit out of the loop. Okay, so for example, a common sentinel value is -1. If you're wanting to accept just positive numbers, or you want your input to you want your while loop to keep running as long as they enter in something that's not -1. So this is an example of some code that's going to add up a bunch of numbers from the user, and as long as the number that they type in is not -1, it will keep running. So initially the number and the sum are both set to 0. So initialized. So because we're creating a sum, so we want to start it off at 0. Initialized. Let's try that again. Start at 0. And then we add the number to the sum, and we'll see why we put the sum plus equals number at the top and why we don't want to put it at the bottom in a moment. But we ask the user to type a number and then -1 to quit, and then we store that. So this is our prompt, and then we store get the number from the user, and then if that number is not -1, we loop and we get another number. We add it to sum and we get another number, and so forth. So that's this add to sum. Whatever the number is, we add it to sum. Okay, and so this would be a while loop that's going to continue running, and then when they type -1, so -1 is our sentinel value, then the loop is going to quit, and you'll have the sum of all the numbers they entered after that. So why is it that we want this? We don't want to put the sum below. So this is bad. We don't want the sum down at the bottom. And it just has to do with the last time that they type in a number. If the user were to type -1 in, which is our sentinel value, the one we don't want to add to all the numbers, then we would add that number to sum and then hit the while loop test and quit out. And so this would, if it was reordered, if sum was the last thing, so if it was reordered so that you've got your print and then get and then add, if this was the order, then when you do the last one, -1, this one's going to get added to the sum, and that's unintended. We don't want that to happen. And so that's why the add is actually put up at the very top instead of after you get the number from the user. Okay? And the very first time this runs, it's fine to have that there because number and sum are both starting at 0. So when you add that to sum, you actually don't change the value of sum. It starts at 0 still. Okay? So that's something to be mindful of, is the order that you do things in when you're using these sentinel values does matter. And if you have it in the wrong order, you might get a little bug, which is that you're adding -1 on the last time through when you don't want to. Okay? So maybe in class or something, or you'll probably run into this error, and just track that order that you're writing your loop body in, and you should be able to find it. Okay, so now let's talk about some string comparisons and how we can use these as flags, as sentinel values in our code. So a couple of string comparisons that we have are the equals method. So these are all Boolean methods. They return Boolean values that you can use for strings, and they're provided in the Java string class. So when you're comparing two strings for equality, you want to see if they're exactly the same set of characters. Then you use dot equals. So you'd say string 1 dot equals string 2, and in this case the order doesn't matter. You can do string, you could also swap these guys, and it's actually exactly the same. String 2 dot equals string 1 is the same as string 1 dot equals string 2. And it's really, really, really important. Don't use, and we'll see more about why this is the case later, but don't use double equals. This is very important when comparing strings for equality. It's not going to give you the behavior that you expect a lot of the time. It's oftentimes going to be false when you want it to be true. And so just never use it. Don't use double equals for comparing strings for equality. Always use dot equals, the dot equals method. So here's an example over here. If I have a name, James Bond, and I say, is this name equal to the string Bond, name dot equals Bond, that's false because Bond is not equal. It's not the same characters in the same order as James Bond, okay? So those would be false if I were to do name dot equals Bond. Now another really helpful method for strings is the contains method. String 1 dot contains string 2. That's true if string 2 is a substring of string 1. So that means if you look at all the substrings of string 1 and you find string 2 in there somewhere, then it is then string 1 contains string 2. So for example, the sentence I love Seattle contains the word Seattle. So that's true because Seattle is the substring of the sentence. Okay, so contains is another useful method. Note that the order does matter. So this one, order matters. So order matters in this. In the string, in this case, if I were to do Seattle.contains sentence, I'd find that's false because I don't have all I love Seattle in the string Seattle. Okay? So contains is looking at, is string 2 a substring of this first string, string 1? Order matters. And then starts with is another one that matters as well. String 1 dot starts with string 2. That's true if the first string 2 dot length characters of string 1 are the same. So if I had, here's an example, string busters equals who you gonna call, and string busters dot starts with who, that's true because the first 3 characters, so the first string dot length characters, that's 3, characters of buster are the same. So who or busters matches with that parameter string. Okay, so busters dot starts with who would be true because busters dot substring 03 is equal to who. Okay. So how do we use sentinel values with strings? Well, a common sentinel value is Q or capital Q if you want to quit the program. So here's code that will accept strings from the user and just print out how long they are. I don't know, could do that or something. But just accept strings, and then when they type Q, it quits out. Okay? So you'd first ask for a string. You can get the first string from the user. Please type a word, Q to quit. And then while that string is not equal to Q, that's when we'd want to get another word. We can print out the length, and we'd ask for another word, re-update what string is to the next, and that's the whole loop. When they type Q, so once they type Q, so if stir dot equals Q, is that true? Then not stir dot equals Q would be false, and we'd quit the loop. Then, that's very hard to read. Then we would quit the loop. Then we quit the loop, and we move on, okay? So that is how you can use a sentinel value, like a character, like Q or whatnot, to stop a loop. Okay, so this brings us to our next topic, which is input validation. Now that we know how to compare strings for equality, we want to start thinking about how we can make our code robust. How we can have the so robustness is where you can handle lots and lots of different user inputs, and our program doesn't crash or doesn't do unexpected behavior. Namely, if they enter something that's invalid, that doesn't match with something that we expect, then we can, we know how to handle it, and we reprompt, and they get caught until they enter something we expect, okay? So it's really good to make our programs as robust as we can, because we might have unwitting or malicious users, so users that aren't careful or aren't paying attention, or users that have something evil in intent, and they can try to break our code or break our programs, or unintentionally or intentionally, and so we want to try to think ahead and say what might break this, or what might be invalid, and make sure that we handle that in our code. So this is an example. You know, we want them to enter something that at least starts with Y or N. You know, it doesn't have to be exactly Y or N, but maybe it just starts with it. And so, you know, they type foo in. I'm like, I don't know what to do with that. They type shoe, they type blue. Finally, they type something that starts with a Y, and we say, fine, I think you meant yes or Y, and so then we continue on, okay? So that's an example of creating a robust program that takes in any input and will keep looping until they type something that we expect. And we'll see that De Morgan's law actually comes up while we're doing these kinds of input validations. So here's an example. So suppose we get a string from the user and save it into a variable, we can call it choice. We're going to write a Boolean expression that's true if choice starts with Y or starts with N, and false otherwise. So we just want to know, okay, if they typed in a string, we want it to be true if it starts with Y or starts with N. Okay, so take a second and try to write this Boolean expression, and then I'll show you what the answer is. Okay, so hopefully you came up with this. Choice starts with Y, or choice starts with N. So this is true if they start with Y or they start with N. Okay, so now negate it. So go ahead and use your De Morgan's law to negate this statement, so that instead of choice starts with Y or starts with N being true, you want it to be true if it doesn't start with Y or N. Okay? So what would that look like? And simplify your De Morgan, your expression, so there's no parentheses. Okay, so the answer is not choice starts with Y and not choice starts with N. So this would be true if the string doesn't start with Y and it doesn't start with N. So these would be all the cases that we'd want to re-ask. We'd want to ask again if it doesn't start with Y and it doesn't start with N. And anything else, like if it did start with Y, then this would be false, and if it did start with N, then this would be false. and so then we would quit the loop in that case. All right, so let's use the Boolean expression to loop until they type something that does not start with y or n. To loop until they type something that does, it should be does start with y or n. We want them to type, and it needs to start with a y or n, so we'll validate their input so that it does after this. So here's the choice. While it doesn't start with y and it doesn't start with n, we say, I don't understand or whatever, please enter y or n. We get we update choice to the next string from the user, and that's literally it. So after this loop is done, we're guaranteed here that choice starts with y or starts with n. Y or n. So we're guaranteed at this point, after the code, after the while loop, that the choice is going to start with one of those two letters, and so then we can handle we can handle conditional code afterwards, because we can say, okay, so if they said y, we're going to do this, and if they said n, we're going to do that. And if we didn't do that to begin with, if we didn't have this input validation, then our code might work incorrectly, because we wouldn't know how to handle something that wasn't y or n. We wouldn't know what to do if they typed something like G or B or A, and so then this forces them into one of those two letters. Okay, so that's how we'd validate input. If the user types in anything that doesn't start with y or n, this loop test will be true, and they will be reprompted. That's effectively what we're doing here. Okay, so write a code snippet that asks the user for a number from 1 to 10. So now this is not a string 1, but a number 1. And if they type in a number that's outside the range, reprompt them. Okay? Do not worry about the user typing in something that isn't a number. So if you tried to use a scanner and you use input.nextInt and they type something that's a string or something else, it actually breaks right then and there. So don't worry about that case. You might run into that if you try to do this. Just assume that they type numbers in, and if they type something that's not a number, then you can then don't worry about it. So assume that, but you just make sure that those numbers are in the right range. If they type something that's not in between 1 and 10, then you should reprompt them. Okay, so pause the video, go ahead and try this out yourself, and then I'll show you the answer. Okay, so here's the general structure of the code. You first get a first number from the user, and then while that number is outside the range, so while it's less than 1 or it's more than 10, those are the two, that's kind of our range of numbers, right? Is we want numbers that are 1 to 10. So if it's less than 1 or more than 10, we'd ask them again. We'd say type a number from 1 to 10, and then we'd update number to their next number. And so this is going to continually ask them till they type something that's between 1 and 10. Now another thing you might do in this last example, note we have some repeated code. We have some redundancy here, right? We say type a number from 1 to 10, int number equals input.nextInt, and we have the exact same two lines of code basically, minus the minus this part, right? Because we don't need to redeclare the int. We already know it's an int. We're just updating. This is an update. And this is redundant, and it's not very pretty to look at. So a slicker way of doing this was thought up, which is to write what's called a do-while loop. And so the do-while loop reverses where the test is. So instead of having the test be the first thing, so this is where we test first, we instead do a test last. So this is the general structure for a while loop is over here. That's what we're used to. That's the while flow chart. You test if it's true, and if the condition is true, you loop, and when the condition's false, you exit the loop. In the do while loop, you reverse the order, so instead you always do the code the first time, and then you just redo the code. You go back up to the top if the condition is true. So you put the test at the end. So test comes at the end instead of test at the beginning. Okay, so this, you're going to use a do while loop if you want the loop to always run at least once. So no matter what they type, if you guaranteed you want to get at least one piece of information from them, then you're wanting to use a do while loop over a while loop, because you want that to run once no matter what, and then go back to the top if they do something that's invalid. So here's the syntax for it. It's instead of writing while test curly brace, close curly brace, so the syntax for the while looks like this: while test open curly brace, close curly brace, some code. Now we say do at the top, open curly brace, close curly brace, some code in between, and then you put the while test, and there's a semicolon at the end of that at the bottom. And so note that this test is at the bottom. That's to remind you that the test is happening at the end, that the test is the last thing you do, and then if the test passes, you go back up to the top. So if the test passes, you go back up to the top of the do, and you run it again. So the do while is a nice way to handle always doing code once and maybe repeatedly doing it again, which is really what you do for input validation. You're always going to get input at least once and then repeat to ask again if they give you bad input. So let's refactor that last example so that it becomes a do while loop. So go ahead and think about it, and then I'll show you the answer. You might run into a compiler error, which is if you, let's go back to this one. If you just strictly put your number inside the do while, then it goes out of scope where the while test is happening. Because remember, the curly braces, those are going to denote this way. Those are going to denote what the scope is of the variable. So you might need to push that variable in a different place. Okay, so go ahead and pause the video and give this a try, and then when you're done, resume. So this would be the answer. We declare the variable up above the do, because if we don't declare it up there, then it doesn't exist. So it's if this variable is inside, then this doesn't compile. Because the scope of the number would be just inside those curly braces, so the while test would not be able to check against it. So we have to put the so we wouldn't want to put it inside the do. We just declare it up here, and then it gets initialized here on the first run through. Initialized on first of the loop. So the first time the do happens, it gets initialized there. So now note, we don't have to prompt more than once. We don't have to write the system.out.print more than once. We can write it just once now. And the only thing that really changed was that the while is at the bottom, and we had to declare the variable that we're testing before the loop. Okay, so that would be how you could do a do while loop. Okay, so that's it for today, and I'll see you guys on Monday, and we're going to start our guessing game project then. So yay, guessing game.